Hello and welcome. Welcome, it's good to have you. You can see on your screen, you've reached the MIT xPRO informational webinar on the upcoming program, Professional Certificate in Data Engineering. We're going to learn all about this program here together with program faculty. The two creators of this program are here with us. And we're going to learn two key features as we make our way through this next hour together. Firstly, we're going to be learning what this program is all about. What can you expect to learn? What are those details on the curriculum and the learning objectives for this professional certificate? And secondly, we're going to be learning how the program is delivered. So in addition to what is contained within the program, how is that program delivered? What is the day-to-day experience of being a participant in the program? So we'll give you some of that tactical information as well as some of that clearer understanding of the direction of this program and what you can expect to learn as we all learn together throughout our time here today. So with that, as I mentioned, we are joined by our two program faculty, Professor Williams and Dr. Sanchez. They are both here with us today to tell us more about this program. Professor Williams is a professor of information engineering at the MIT Department of Civil and Environmental Engineering. Would you like to jump in and say hello, Professor Williams?
Thanks, Marie.
You're welcome. Thank you, Professor Williams. Dr. Sanchez, you got to see him a moment ago.
Hello, everyone. Looking forward to covering the material here with you today.
This is a teaser of what's to come and also a good time to remind. So you can see the pedagogy or the mission here at MIT xPRO is to really take the incredible wealth of knowledge and expertise that's housed within MIT faculty, these world-renowned experts that you'll learn and hear from today, and make that accessible anytime, anywhere. So MIT xPRO designs its curriculum around cutting-edge research in the neuroscience of learning. So we think a lot about adult development. We think a lot about what works well for adult learners. And we apply that pedagogical approach to our learning. And really what that results in is an application-focused curriculum, a curriculum that helps you take theory, that helps you take concepts into the real world, into a place of action. I'm helping you to build skills on the job. So these programs are designed to blend in parallel with your full-time roles, and they're designed to really fit around your other responsibilities, a professional certificate in data engineering in particular. So we know that as technology proliferates, data is evolving into a true strategic asset, and the demand for data engineers and their specialized expertise is growing in tandem. So you see some information at the bottom of your screen. The average annual pay for a data engineer in the United States. Data engineering was the fastest growing tech occupation in 2020, because before data scientists can glean information from data, they have to be able to, the data has to be architected, warehoused, accessible, and data engineers are responsible for building this infrastructure. So it really is a fundamental building block. And it's certainly in high demand. So as you think about data engineering, as you think about stepping into a data engineering role, this program is really designed to help you get job market ready. That's why we're showcasing the annual salary here. We're talking about this being a fast growing industry or a fast growing occupation, because this program is really geared towards helping you to be job market ready. So there's a lot of that built into the program. We'll touch on some of that later, some of those career opportunities and developmental opportunities for you in the program, but really helping you to learn the essentials here as you build your portfolio, as you build your skills throughout this 6-month program. We estimate 15 to 20 hours per week, and this can be designed around a schedule that works for you. So a big part of what we do is we've designed the program to be a blended program, allowing you to touch into the content around a schedule that works best for you. So one of the things we're going to be, and if you're just starting out in coding, you might be, wondering if is this course going to be right for me? Do I have the right prerequisite knowledge to be successful in the program? And on the other side of that, strong math and a minimum of a bachelor's degree is recommended. It will certainly set you up nicely in the program here. And we really designed the program for beginners, for those who are just launching out in their career, building a career, or making a cross-lateral switch from a similar industry. So some of the job titles that this program will prepare you for are listed here on the right: data engineer, data science engineer, data software engineer, several others here. And so again, a heavy career component blended together throughout this 6 months. The key takeaways for this program, and the professors will get into this in a little bit more detail, but again, just really helping you to launch or continue your career in data engineering. So you're going to learn to code in Python, use SQL to create databases, wrangle and analyze millions of pieces of data using databases in Python, understand how networks work, including IPs, security, and servers, manage big data using data warehousing and workflow management platforms, use cutting-edge data engineering platforms and tools to manage data. We're going to showcase some of those tools for you here today on this session. And then finally, explore artificial intelligence and machine learning concepts, including reinforcement learning and deep neural networks. So as you can see, a comprehensive end-to-end program here, a professional certificate in data engineering. And here to tell us all about it are our two program faculty. Firstly, we have Professor John Williams, and here's a little bit more information about his research and industry background. You can see he holds a BA in physics from Oxford University. His research focuses on the application of large-scale computation to problems in cyber-physical security and energy studies. Professor Williams is a director of MIT's Geospatial Data Center. And from 2006 to 2012, he was the director of the MIT Auto ID Laboratory, which invented the Internet of Things. You can see a list of his accolades. I won't read them all off to you, but some of my favorites. He's co-authored over 250 journals. He was named as one of the 50 most powerful people in computer networks, alongside Bill Gates and Larry Ellison, and he consults for companies all across the globe, top companies here listed. So a lot of a rich experience folded into the development of this program, together with Dr. Sanchez, who holds a PhD from MIT. He is the executive director of MIT's Geospatial Data Center, as well as an architect of the Internet of Things. And he also consults for several top brand companies. You can see them listed here in his bio. And certainly Dr. Sanchez brings a wealth of teaching experience as well, having created online resources he has over 10 years of experience with learning management systems and with producing educational videos. So as you think about this program, as you think about the context, these are the knowledge and the expertise coming from your faculty here that have been woven throughout the program. So they're here to tell you all about it. I'm going to hand over the spotlight. So with that, I warmly invite into the spotlight our two keynote faculty presenters, Professor Williams and Dr. Sanchez. Thanks again for being here today. Over to you both.
Thank you, Marie.
Thanks, Marie. So Abel, I see the stock market is really, what's the word, active today.
Yeah, don't remind me. No, it certainly is. And, I think one of the frequent exercises is how can we get some insight into investing? And interestingly, I think, this has been rippling throughout the financial industry. I think starting last year, there was a recognition of the non-traditional investor, the ones that invested in GNC and or GMC and other, GameStops and so on, and started to move the market. And now, a lot of the Wall Street investment houses are mining, the forums and these sort of places to try to get some insight as to how these communities are moving, to try to, again, understand how, valuation is going to move. But all of this has to do with data. John, what do you think when you think about data?
That's what I was thinking is that it's not only to do with data, it's to do with recent data, that the data last week about the stock prices doesn't really matter very much. It's kind of what's happening now. And, one of the things that's happened quite recently is the systems we're building now, a lot of the data is what we call data in motion, that it's this fast moving data that is flowing past us that we're trying to analyze and then we really don't care that much about it. Now, there's other data that's kind of long-lived, and it does matter what happened last week or a year ago. And an example of that would be healthcare data, where you're trying these drugs that kind of last. I mean, the trials last for 6 months or a year. That it's only after that time that you get insight into what's really happening. So there are very different kinds of data, and I think we've been in this area of computation now for quite a while, but this area of data engineering is fairly recent. Abel, what's your sense about what's happened and why this field actually exists now?
No, that's a great point, John. And that, we've been touching data our whole lives, right? You really can't do computation without touching data. And in many ways, as we, dug deep into this field, we realized how poorly understood it is. And in fact, some of the first publications that talked about, the engineer, the rise of the data engineer, are only about 5 years old. And so, that gives you some understanding of what this new role is and what this new position is. And as you see here, at this pyramid, and that sometimes it's called the hierarchical data needs, you can see how there are different titles there, depending on where you work. It might be called something different. But I think the three that you see there at the inner part next to the pyramid, data science, data analyst, and data engineering, are the most common. And you can't do nothing at all, unless you have data engineering. You need to be able to move, to collect, to process your data before the data analyst can do anything. And, at a higher tier, the data scientist can. And interestingly enough, there has been some criticism in the industry about the role of the data scientist, arguing that, some have called it a luxury employee, that if you have good data engineers, good data analysts, you could do without the data scientist. But whether that's true or not, I think the core requirement before you do anything else, and many companies make this mistake, they get funding or they start a new data practice, say, and the first thing they do is they go out and hire data scientists. And then, of course, they spend the next 2 years doing data engineering, right, before data scientists can do anything. And so, you can see there the importance, as Marie mentioned, it is one of the fastest growing in this area, and it is essential. You really cannot do anything in your organization until you address this. John, how do you see it?
Yeah, I mean, I think this pyramid also reflects the number of people that you kind of need in an organization. At the very top level, the people doing machine learning and AI, you don't need many of those. But to handle all of the data that's coming into your corporation and to set up and maintain the systems that are running, you need a lot of people. I know in MIT, and we're not that big an operation, the number of people just supporting the SAP, enterprise resource planning system, we've got about 50 people. That's all they do. Now, that's just one data source would be your ERP systems that tell you about number of employees you have, where they're spending money, etc. But in a lot of corporations today, you can imagine if you're running Uber, that you need to know, where are all the Uber drivers? Where are all the people that need to be picked up? And that data needs to be analyzed, and you need to be able to do real-time pricing on how much it's going to cost for somebody to get from some location to another location. So these are highly sophisticated systems. And today, almost all of them are running in the cloud. And so when a lot of the things that we're going to be talking about are these kind of large scale systems that are handling large volumes of data every day, and they're making decisions about that data. For example, when you click in Amazon and you buy a refrigerator, that message, that event triggers lots of other systems. And so we're going to be introducing you into this kind of ecosystem of what happens to data as it flows from wherever you're gathering it up into this pyramid of data analysis, data cleaning, and then eventually perhaps some machine learning on it. So Abel, is that your sense of, where this is heading?
Yeah, and as John mentioned, there is a journey here that organizations need to go through. You need to get good at data engineering, and even within data engineering, some of the leaders in the fields, we've heard them give talks, about the long journey that an organization goes on just to master data engineering. And there's different levels of maturity. A lot of people start off with the traditional relational database management systems, and then they start to add some cloud components. Then they start to do some automation, and later they start to do data warehousing and break that up into a distributed set of components that are much more agile. But this is a long process, and as John said, there's a lot of opportunities and a lot of personnel requirements to be able to do that. And you don't end there, right? You need to continue in that journey when it comes to being able to ultimately derive value. And the tool set when it comes to this can be pretty sophisticated, meaning there is a lot to learn, and there's a lot of legacy there as well to take a look at the tools.
Yeah, Abel, I was just going to pick up, there's a question here by Christine saying, has data analytics been around much longer than data engineering? And the answer would be yes. We've been doing data analytics for 30 years or more. Typically the Excel spreadsheets, that's what they're doing, is data analytics, that you're averaging things, you're looking for distributions, etc. Now, what I should say is most of this, there isn't mathematics involved, that it's good if you know what an array is, or a vector or a matrix, but really we're not applying statistics. And, statistics is one of the best bases for machine learning. If you are becoming a machine learning person, then you'd have to learn all that. But for data engineering, it's not really about that at all. It's more about, these systems that we're putting in place to pick up data from devices. Today, IoT, Internet of Things, all these devices are producing data that may or may not have value. There's a great diagram that we have of the modern farmer sitting in the tractor, and all you have is screens around him. And my sense today, it's funny, both Abel and I have been talking about our desktops, because we've been spending time really building up our desktops, and they look very different today to 3 or 4 years ago. Today one screen is just, you can't see enough to be able to really operate. So the things that allow us to wrestle with all this data is the tooling. And as Abel was saying, these are some of the tools that we're going to be covering. Abel, do you want to say some words about them?
Yeah, sure. And before I go in, I wanted to touch just based on this transition. And I think at times it's hard to put your arms around this, because, we saw that pyramid, but what does all of this mean? And you can think of it as at a high level as you have collection, you have some, storage after, you have to collect it, and it comes in all sorts of, well, let me say what those 4 areas are. You have collection, you have storage, you have processing, and then you have some consumption of this, right? So at a high level sounds pretty approachable, right? However, when it comes to collection, you have to think that you have many different types of data sources, right? You have certainly your applications, right, that are online, and a lot of times these are key value pairs. Then you have your logging and monitoring, right? That's another pipeline of data that's coming in. Then you have your IoT data, as John mentioned. Each of these has different granularity, different frequency, different velocity. So when it comes to storing these, you need to address these in kind, right? And there's all kinds of different types of data stores that we could talk about, and you will see in the course as well. And then once you get through all of that, then you have often an ETL layer in between, before you go to processing. You extract, you transform, and you load. And for generations, people have done this. Now there's better tools for it, but it's still the old thing, right? That, you get something that looks like a triangle and you need it to be round. And so you need to do something to it to be able to derive that roundness, right? And so you have that whole layer of processing. Once again, depending on what you're doing, the frequency, the volume, etc. There are different tools that will allow you to process this. A lot of them are moving to the cloud. And then there's an entire layer of how to consume these and, front-end clients and so on. But, moving back, you can see here the richness of this tooling because of all that requires to be done. And certainly there are still, I like to make fun of relational database management systems just because they're old. However, as many have pointed out, leaders in the industry, SQL is the, lingua franca of the data world, right? Although it's old and it's clunky and, people complain about it, even brand new tools such as BigQuery from Google has adopted SQL, Databricks, and other big analytical engine has adopted this as their primary way in which to interact. And so we start off, there, but there's a lot more to go. So John, there's a bit of an intro. I don't know if you want to pick it up from there.
Well, no, I'd like to, because I was thinking the other day that I was looking at some numbers for the global productivity, the GDP of the world. And if you look at it over, from the, 0 BC through the last, 20 centuries, 2,000 years, basically, it was flat for, the first 1,000 years. Nobody was producing anything much. And since 2000, the world's GDP was something like 35 trillion then in 2000. Now it's over 120 trillion. And so you have to ask, what's made us all more productive? Because it's not like there are that many more people. So the productivity is due to this tooling. And today, a programmer or an engineer is handling roughly 100 times more code than they did 10 years ago. And so the tooling is critically important. And, the beautiful thing about it is the teams that you need now to really operate and to move fast are not thousands of people. That you have 10 really good people, you can move a lot of data. And so we're going to introduce you to the tools that you need to get to that stage where you can handle lots of applications. You can arrange that messages are transmitted between them. So today, when I say handling code, doesn't mean that you're writing code. The job today is more to understand these packages or these applications. And I should mention another word, that the language that we use, you'll catch that now and again we talk about packages or libraries or this or that, and it may not be clear what we mean, but after this course you'll understand exactly what the language is. And to get a job, it's really important that you speak the language of this world. And the tooling kind of gives you that we'll be talking about GitHub and GitHub repositories, GitHub repos, for short. And you have to know what they are. Anyone in this field will know about GitHub. And it's used for managing code. And a lot of you, over 50% of you out there have had, 3 years or more experience. And so I'm sure you've heard of that. But now there's a lot of other tools that you need. We're in this world of what we call continuous development, continuous integration, where companies like Netflix are updating their code 20 times a day. It used to be that it would take 3 months, 6 months to just have one update to a piece of code. Now these products are being updated all the time. And it's not as if these products are standing still. They're all changing all the time. So actually maintaining something that is stable and can handle all this data passing through it is quite a challenge. Abel, we haven't even got to some of these tools. I just mentioned GitHub. What's your next favorite tool?
Sure. So I wanted to talk a little bit about databases and their progression here. And so I think this would address, some of the, certainly Firebase and potentially the SQL, NoSQL there. And, to say that at some point, people were saving data in files and then trying to run code against them. And eventually somebody said, hey, let's do that in a more organized way. Right. And as John mentioned, some people have done this, run analyses on a spreadsheet, but eventually you hit some walls. And even if you're working within Excel, and I've done my time within Excel and know about the frustrations of that can be, especially if you come from an environment where you're used to being able to have control, you hit some walls, right? And then you can move to an environment that is, say, a database, right? And where really this thing was built from the ground up to be able to do certain things that are much easier done in a database, right? You have more speed, you have more functionality that is built in. It just makes your life easier. And plus, doing persistence and storage, this is meant to be accessed not just by you, like Excel, but it's meant to be accessed by a group, right? And so you have some of those benefits. And this is why a lot of the world still runs, with a database in the background in addition to their applications. And then, you start to add more and more functionality. You want to, apply more code, and you start to hit some of the limits of that. And this is why you see Python within the data side of the world being really a great companion and really doing a lot more that allows you to free yourself, say, from the database and leverage that freedom that you have when it comes to writing programs, right? Because SQL, again, it's sort of not meant for that. And so, you have that evolution. And as you move through those tools, right, at one level you have, say, the data, the spreadsheets, and then you have the databases. And when it comes to databases, there's a progression that has gone on as well. As the world of the web came in, the traditional relational database management system was too structured, too rigid. And so you needed a little bit more freedom, more flexibility. And this is what NoSQL came to do, right? It didn't have the same type of rigidity when it came to the way in which you store data. It was happy to take pretty much anything you gave it. And there was an evolution that went from there. So I've covered a little bit there when it comes to, the progression of databases. But John, maybe you want to say some things about some of the other tools.
Well, yeah, I'd like to pick up on, underlying a lot of these tools is Python, but these tools may be in other languages as well. Often we don't care. An example of that would be Kafka. It happens to be written in Java, but when we're going to interface with it through what we call an application program interface, an API, and we're not going to really care that it's what the language is that it's written in. We're going to be asking it to do things by sending it messages and passing it data in data streams, and it'll take care of the rest. So, these computer languages are important, but not that important these days. Most of what you're doing is interfacing with these APIs that you can ask this application to do something, it'll do something, and pass you back the result or pass the result on to another application. So today we're setting up pipelines, and Abel kind of went through exactly what a pipeline consists of. It's usually that you're gathering some data, and we call those data producers. You'll have something like a broker. So we'll have Kafka as an example of a broker, MQTT brokers. There's several of those, and we'll talk about these protocols that are used for transmitting large amount of data. But these brokers then have consumers. So these are people that are interested in the data. And a lot of what you'll see is that you'll want to put triggers on these databases so that if something happens, you're informed. And when I say you, I mean your application. So these systems today are what we call event-driven, that something happens and that event triggers some application to do some processing, and then it fires off other events to the consumers. And the consumers then process the data and fire it off to other things. So the world that we're living in really is a message-driven world, that these applications are long-running applications. It's not like we're just spinning up a program for 10 minutes and then exiting it. These applications are sitting there like Kafka, and they're executing day after day after day. And so we're in a very different world to, the world on our desktop, where if I spin up a Python program, I ask it to do something, it does it, and that's it. We're building on that. Now, fortunately, Python has lots of libraries, and some of these libraries are very powerful. So pandas, for example, will take complex data structures. So if you make a SQL query to, one of the databases that Abel was talking about, you can pull the result back into a pandas structure. And then you can manipulate it there, and you can do it very much like the Excel spreadsheet, but you can do it at scale. So we'll be showing you how to operate a lot of these tools. We'll be giving you projects, and you can put those projects in your portfolio. And that's important because when you go for a job, they're going to ask you, what are you familiar with? What have you done? And typically today, it's not presenting somebody a CV that they're going to ask, show me your GitHub account. I want to see what you've actually touched. And so we'll give you these projects. One of them that we have, you're reading in 100 million line file. Now, that can be quite difficult. And typically that wouldn't be that large a file today. But these tools will allow you to handle it data at scale. Abel, what's your sense?
We're getting pretty deep here into what the content is and what you will be learning, but I just wanted to back up a moment here and say that, as Marie mentioned, there are no requirements for the course, and we divide this into 3 blocks. And the first block is we start off gentle. we give you the traditional database, and we walk through SQL, where you design your data models, and you populate your databases, and you ask queries, and the introduction into this world, the equivalent of analysis and design of data models. And we also cover Python and so on. But meaning we start off gradually. This is the first phase, the first of the 3 chunks. And then on the second one, we do, ramp up and start to go into, all of the richness that has come after that, that relational original design. And then on that third one, we start to get more into big data platforms and some of the other tooling that you get. I mentioned just simply to give you some context and for you to not be frightened, just so that you see that, we're going to walk you through this field, and although it can sound overwhelming, there's really, I think those 4 functions that we mentioned, you collect this data, you store this data, you process this data, right? And the tooling that we bring to it is, it reflects what has happened in the world, right? That we need a lot more richness, a lot more flexibility, and what John mentioned, these pipelines and so on. So anyway, I just wanted to give that a bit of context so you wouldn't feel lost, because I know I do it as well. I forget, and I start talking the specialized vocabulary that John mentioned that you will pick up as we go through the course, except we have the benefit of having been through it already. John?
Yeah, we should say that we've taught this stuff to people with no background in computing.
Right.
I mean, it does help that if you've got some background, for sure. But like I say as well, there's very little mathematics at all. That this field doesn't depend on that. If you're going to be a machine learning person, mathematics would help, and statistics as well. But this is more about building these, I call it the nervous system of a company. A company has to be able to monitor itself, what all its people are doing, and it also needs to understand the outside world, or at least the part that it's, selling products into. we go over, there's lots of use cases of how the world is today. And there's a great set of talks by Adrian Cockcroft, who was with AWS, Amazon Web Services. And he talks about IT today and IT as it used to be. As it used to be, this field of data engineering would have been just keeping the email server running. Whereas today, this stuff is the heart of the company. If you tore out the data systems, the company will die. Companies today kind of exist based, continue to compete based on these kind of systems. That if you can do something faster, better than somebody else, you're going to outperform them. And today, you can't do it without data. The example, that we like to give is Netflix. That Netflix can outperform Hollywood because Netflix is watching you watch its movies. It knows exactly how long you spend on each scene, the kinds of things you like to watch. So when it produces content, its risk is so much lower than Hollywood. And we're seeing that in field after field now, that basically data and data that you understand reduces your risk. And that allows you to compete much faster, much better. Abel, that was high level waving, okay?
I think, in some ways, I'm just trying to give you a little bit of context of why, these matters and why it's being used. And, you start to see it everywhere. John knows that I like to follow sports and the development of sports analytics. And you already see, the manager that gets hired because of their use of analytics, and the one that gets let go because he doesn't understand, how you can leverage and pick up insights. And one of the interesting things, I think most of you are in the US and you might know of, the playoff games in the NFL this weekend. And football sort of lends itself to this. And by the way, it's an amazing game.
Last night was amazing, right?
But football sort of lends itself to this. It has that 40-second pause between plays. And so you can actually stop, think about what you're going to do. And as you switch also from offense to defense, you see, the quarterbacks, you see the coaches speaking with them, and they all have tablets in their hands. They have, I think they cut a deal with Microsoft, so they have surfaces, and you can see them reviewing the plays. Because a lot of times, you often hear in sports analysis shows, well, they're going to go home, they're going to watch game film, they're going to figure out what happened, and then next time they will be ready. Well, it turns out that now people are making those adjustments on the field. They're starting to look at the patterns of play. They're starting to try to understand, say, the defenses or how the offenses are operating. And so we're, just taking the first steps on this. However, you can see the importance and the relevance in the field of sports and in many others, like the one John described. And you can see that unless you're on this journey, you're going to be in trouble. John?
No, I was thinking the one tool that we missed out here is Google. It's an amazing source. You want to do something, and so you set out and you hit a wall of some kind. There's an error on your machine, something. You can look it up. I mean, this area is actually, what we call a friendly learning environment. That it's not changing that much. I mean, I'll say that with quotes. But there's information there that can help you. As you're gonna hit some bugs or some problems that maybe your machine is not quite set up as we've intended. Now you can either get help immediately, from the LAs, the learning assistants, or you can look it up yourself. And what we want to get you to the stage is where you can actually survive on your own. After this course, you'll know enough that you may not have done something, but you will be able to teach yourself and learn how to do it. We want to give you that confidence that it's a friendly learning environment, but it's also what we call a contact sport, that you have to do things yourself. That Abel and I, beat our heads on things for, 4 hours sometimes to find out one little thing. But once you've discovered it, you know it forever. And so a lot of the time it's building up this confidence that you know kind of the building blocks. So we're going to kind of give you a map of this whole area. We're going to take you to, I call them the mountaintops, so you can see down what's in the next valley. We may not explore everything, but you'll have seen the landscape. And often you can have a whole career, as Abel was saying, just in SQL. Yeah, that will be that career is going to be around for a long time. But there are other areas as well here. All of this tooling will allow you to operate and do things in this data engineering environment. Abel, is there any other high-level things?
I think we're pretty much at time for Marie to come back. Marie.
Thank you, Dr. Sanchez, Professor Williams, for taking us through this content on the session. But we did want to showcase for you sort of the unfolding of these sections or these modules across your learning journey. So the program is divided into 3 main sections, and you'll see those module details outlined here. We encourage you to come back and take a look at some of these details so you can really get that understanding of how the course unfolds and what those kind of through lines are throughout these 3 sections of content. From there are assignments and portfolio projects are really, again, aimed at helping you to bring your learning into the real life. So you're going to be creating a tangible GitHub portfolio. Your professors mentioned that portfolio, and it goes a long way in showcasing your learning, as well as provide you with something tangible you can take in with you to a job interview. So this will be completed based on what you learned in the program, sort of a culmination of your learning, and something that you can really take away from this program and use again and again. The coding exercises are integrated throughout the modules using Jupyter Notebook, so you can practice really building those composite skills to prepare you for the assignments and the portfolio projects. There's a lot of assistance throughout this program. In addition to your program faculty, you'll have learning facilitators. These are industry experts who have been selected to come into the program and provide that day-to-day teaching support. So in addition to Professor Williams and Dr. Sanchez, you'll have your learning facilitators really at the helm of your learning experience. They're going to be giving you individualized feedback on your assignments, detailing for you how you can improve as you go along. They're on the discussion boards with you and your peers, helping to drive engagement and push your thinking. And of course, they're hosting office hours as well, which is a chance for you to turn on your video and your audio and engage in live synchronous learning with these subject matter experts. So your learning facilitators are a big part of your learning experience. They are sort of at the helm of that day-to-day learning experience. And throughout your time in the program, those office hours become really critical, particularly as you're working with coding and through some of these more technical components. You can get that personalized support, that career guidance and network development through your learning facilitators. And so you'll see sort of in summary here, you'll have insights and coding demos from renowned MIT faculty, as you've seen today. You'll learn that market-ready data engineering skills, so you can really graduate from this program, complete this program, ready to go into the job market. And of course, that GitHub portfolio, a big asset as you move out of this program into your next venture. In addition to that peer network, sort of when you join the program, one of the first returns on your investment is the chance to broaden your professional network and gain peers and colleagues from across the globe. And that broadened professional network is something you'll take with you outside of this program, those relationships that you build. But you also have a chance here to earn a certificate. This is a credential from MIT xPRO, and this credential will certainly go a long way in showcasing your learning and formalizing your training in data engineering. So a lot of big advantages as you think about this program and some of those big assets that you'll take away. For those of you who are really wanting to center in on the career preparation, here's some information about the learning facilitators and some of the lessons that they'll be guiding you through. There's a variety of skills you'll be touching on, hard skills that are technical as well as soft skills. How to talk about what you love. What is your elevator pitch? How to craft your LinkedIn profile, your cover letter, your resume, negotiating salary. All of this is built in not only to the elements of the coaching that you receive, but also with exercises throughout the program. So these are detailed assignments that really hone in on helping you to build your personal brand, communicate effectively across technical and non-technical teams, understand agile development, reflect on your own skills to know where to target your next learning experience, and really helping you through that entire job search and interview process. This is an example of that digital certificate of completion that we spoke about. This is a digital copy, so you can put this on your LinkedIn or social media, bring it with you to your job interviews. And again, really helping to formalize your training. We talk a lot about the relationships that you build in this program with your peers, your faculty, your course leaders, your learning facilitators, and this larger community at MIT xPRO. All of that starts right here, right now, with getting connected with a program advisor. So we have here with us on the call today a team of program advisors. Christina is with us here today. Thank you for joining, Christina. We have Marie here as well. Marie Longchamps, another program advisor. They are the course foremost experts when it comes to all of the logistics for the program, all of the course policy details about the evaluative criteria, assignments, deadlines, and also the registration and enrollment process. So we're at that phase now where you're filling out your application materials, you're getting prepared to join the program, and we want to make sure that you have an advisor, a support person to work with between now and the time the course begins. So Christine and Marie are here waiting to hear from you. There's a couple of different ways for you to get connected. So go ahead and get connected with an advisor, but while we have time left, let's go ahead and open the floor back up to our professors here. Is there anything that you'd like to address, sort of jumping in? I see Schuler's message here about full stack web application developers in terms of leveling up as opposed to switching industries. So as folks are thinking about this idea of program fit, is there anything that you'd like to jump in on and address?
Yeah, I mean, in some sense, this would be part of full stack, but full stack typically focuses more on, user interface, so you'd be the kind of front end, the web server part. We're focusing on the slice that's to do with moving data. So it would involve some of those aspects for sure. Certainly we're covering what you might call full stack, except our emphasis is more on the flow of data and the analysis of data. Do you think that's fair, Abel?
Yeah, the other thing that I would mention as well is that in the full stack, there is a lot of attention being given to the front end. And when it comes to the front end, the frameworks, the way you present, the additional language that you have to learn, because today's the front end is the browser, and you need to learn JavaScript at depth, plus layout, plus styling, which is cascading style sheets. And CSS. That's a profession unto itself, right? That's any one of those, in fact. And so there's quite a bit of work there, plus the server side serving, component of that, meaning the back end. And so where you connect to the database would have some overlap with what we're covering here. However, this is much, much more, much more extensive than what's usually addressed in a full stack course, in the sense that, typically you do a data model and some queries of that as addition to the rest of the full stack. However, in this case, we are, expanding through the entire, data cycle, which we covered earlier in our presentation.
Yeah, and I'd kind of add that, any of the areas of full stack would be a full-time profession, like you're saying, Abel. If you're picking up one of the frameworks, that's going to be a lifetime job almost. Cybersecurity, and that would be another area where it's a full-time job. So we're focusing on the data part of it, which, as Abel mentioned, there are kind of 6 stages that companies go through. And, most companies are at stage 1, 0 or 1, which is batch processing. And there's 5 more stages to go through, which makes it a challenge. And so I think we've got a pretty specific focus here, but in some sense, it's also very topical and very general. That because of machine learning, the advances there, data is being valued in a way that it hasn't been valued before. I mean, today we talk about data first companies. These are companies that are focused on data, and many companies, if they're not focused on data, have a problem. That they may not be around for long.
I'm going to jump in on that, and I want to give you both an opportunity for final words of wisdom.
I mean, I just say this is a fantastic area to be in. I mean, one, it's fun. There is, as Abel was saying, there's some pain, getting up to speed, but once you're in this area, it's fascinating. And, we love what we're doing. So we hope, that you'll gain that enthusiasm during this course, that you have to love it because you're going to be spending a lot of time doing it. Abel.
No, I just wanted to, respond by addressing a little bit of Sean's question here that, can you apply it outside of commercial business? And he was talking about public health infrastructure. And the answer is yes. It goes across all industries, in education, in finance, and healthcare, in government, to understand, spending patterns, concerns of citizens, and so on. And this is, going back to what John mentioned, what makes it so interesting, because this skill set takes you to every domain that's out there, which makes it much, much more interesting when it comes to career choices. And as was mentioned already, this is, the highest demand that exists out there. So, it's a great combination of something that is fun to do, has a lot of different career paths that you could follow, and that there's high demand for. So, that's a great, great combination.
Thank you both again, Dr. Sanchez, Professor Williams. It's been an absolute honor learning from you on this session here today. So with that, we're going to go ahead and close out today's session. It's been an honor learning shoulder to shoulder with each and every one of you. And we wish you all a very heartfelt good morning, good afternoon, good evening. Bye-bye.